Nice job with those practice problems. Hopefully you understood them. If you didn't, please reach out, like I said. But we're going to move on a bit more now. So let's talk about string methods. What are string methods? Well, essentially, they're methods that you can use to modify or find more out about a string. And this is extremely useful for any kind of data processing because oftentimes you'll find data like names, dates, like middle names, last names, anything like articles of clothing. They can all be represented as strings because, well, it's words, and words are extremely powerful in the English language, so why wouldn't they be powerful in Java? So we already know how to declare a string, right? So I'm going to create a string here. String test equals A, B, C, D, E, F, G, Java, A, number, whatever, right? One funky string. So what are these string methods? I'm going to show you both how to call each one on the string object and what even calling on an object means. So we have our string right here, right? String primitive. Now I can type it out right here, test. And if I click the dot button, you're going to see all these methods pop up. These are all the methods that you can apply onto a string to change it or find more out about it. So let's start off with the most basic one, which actually deals with booleans as well. So I'm going to make an if check. First, let me delete this stuff. I'm going to make an if check. So this if check actually works out in pretty plain language. It says that if test equals whatever I put into these two parentheses, and pay attention to how the parentheses are oriented, by the way. You can see that these outer ones belong to the if statement, and this inner one belongs to the method. Essentially what it's saying here is if test equals EEE, which it obviously doesn't, then print out the strings are equal. If it doesn't, the strings are not equal. So let's run this code right now. And guess what you think it's going to say? Strings are not equal because whatever I typed in here is not equal to EEE. So then I can change this to EEE. Run that. And boom, the strings are equal, right? Because these two are the exact same. And so how does this work? When I call, and calling means essentially just telling the string to do something to itself. When I call dot equals on the string, which is denoted by this little dot here, because I type in test dot, and then I type in the name of this, which is a string method, I am giving it this input parameter of a string, another string. And what it is going to give me back is it is going to give me back a Boolean. And I can use that Boolean inside this if statement. So I'm basically saying, all right, test.equals EEE, right? So let's check it out. 4e's, okay, 4e's dot equals 4e's. Yeah, this checks out. So that whole thing is going to just mush up into true. All right, and then we can think of that true. It's going to mush up into true. And if it's true, just print out the strings are equal. But then let's say I change this to EEEA. Now replace test with EEA equals 4e's. That's not equal to each other. So then I am going to replace this whole thing with false. And it's going to skip over this section, and then it's going to go to the else only. So that is how equals works. And then another flavor of that is equals ignore case, which essentially just means that I'm going to check if they're equal regardless of case. And then you can say, it tells you what to put right there, another string, right? So I can put EAB, which isn't going to be equal to each other. But say I put these two together, they'd be equal to each other because it's going to ignore the case of the letter. Now, what is this? This is length. This is extremely important, figuring out the length of a string. So let's hop down here. I have this test string right here, right? S equals A, B, B, C, C, test example string. So now if I want to print out S, which is the name of the string, dot length, it'll tell me how many characters are in the string. And this first character is going to be 1, and this last character is going to be 27. As you can see, there are 27 characters in the string. So just like how the last method, we typed in the name of the primitive, which in this case is a string, we did dot to call a method on it, and we typed in the name of the method. Now this method, it still has those parentheses, see? And in those parentheses, you usually put what this method accepts and then what it spits out, and then it'll give you what it spits out, right? It's basically a function. You're giving it something and it spits out something. This one doesn't need an input, so I just create those empty parentheses, right? And it'll still, regardless, spit out a number, and that number is the length of the string. So I think you can see a pattern here by now. All these methods are essentially functions. You give it something, and it'll give you back something. And what those somethings are laid out here. All these methods, it tells you exactly what you give to the string, or like what you give to the method, and what it'll give you back in relation to the string. Let's pick one of these. So let's do contains, right? So contains, what it does, it'll give you back a Boolean, because it's like, does this string contain this other string? So let's do s.contains, and then I'm going to put in a string test. So let's check out this. Does string s contain test? Well, yes, it does. So because this will spit out a Boolean, this whole thing will be, this whole thing will be equal to true. So you'll see when I run this, it'll return true, because this string contains the word test. So there are so many methods to go over here, and there's even more that aren't even on this list, but you can definitely explore those on your own time. But these are the most important that I'm going to teach you here. So let's go on to this one called char at. Returns a character at an index. And one thing you have to, I guess, shift your mind to thinking about in Java is that indices are zero-based. The first letter of the string, unless you're calling length, which is in the first letters, if the first letter is considered 1. When you're accessing it, and the way Java stores it is that the first letter is considered index 0. Second letter is considered index 1, and so on and so forth. So if I was to like label a string, say A, B, C is my string. Oh, A, B, C is my string. Then this first A would be character 0, B would be character 1, and C would be character 2. So how can I use that to my advantage? Say I want to figure out what the fifth letter of the string is. Then I can type out s.char at, and then it accepts a parameter of an index. So this function, this method, takes in a number and will spit me back out a character. So I'll give it an index, which is, let's say I want to figure out what the fifth index is. So before actually running this, let's count. 0, 1, 2, 3, 4, and 5. So this will return us capital C. There we go. And say I want to figure out what the character is at like 12. Oh, it's a space. That's why nothing printed. And then let's say, remember how the length was 27? What happens if I type in 28? We get an error. So this is a error you guys will probably see a lot as you get into coding string index out of range. Basically, it says that you tried to access a number that simply isn't in the string, because this last exclamation mark is 27, and there's nothing after that. This quote simply ends the string. So that is how you use char at. Our index of is almost like the reverse of char at. It tells you, okay, I want to find what number index this letter is at. So I can type in index of, say I want to figure out what the index of the first capital B is. And by the way, it's a first index of. You don't see the word first here because it's implied, but when you use index of, it returns the first time you find this. So say I had like a B at the end here, like a B right there, then it would return me whatever number this was, not the B at the end. So I can actually prove that to you guys. As you can see right here, it'll return 0, 1, 2, 3. It'll return 3. But if I now type in last index of, then it'll return me 27 because I added one more and then one behind the last one, which is now 28, which is 27. Oh, my bad, 26. I guess I can't do math properly. But it'll give me the number 26, which is the last index of the letter B. One quick thing to mention about index of and last index of is that you can actually check for the index of a section. So I want to find the index of the word test. Notice how it doesn't give me like, oh, T is at 8, and then E is at 9, S is at 10, and then the next T is at 11. It just tells you where this first letter is. So T is at 8, and then the T of this first, I guess, search parameter is going to be at 8 within the string. So then let's check the next one. We're going to have substring. It gives you a string. It'll return you a string that only contains the characters from the indexes that you give it. So if I do s.substring, then I say I want to only have the word test. I want to make a substring with the word test in it only. So then I'm going to start out with 8 because I know that the word T starts at 8, right? And then I'm going to go to 12. And let's count there real quick. So this is T is 8, E is 9, S is 10, T is 11, and the space is 12. So why do I put 12? Well, it's because how this works is it actually will only go from 8 to 11 because it excludes the last number. So basically you're saying start at this letter and include it, and then go up to this letter, but don't include it, and instead give us the one right before it. So if I print this out, it'll only give me test. And as I will actually prove it to you by putting something more in. So say test is 11, 12, 13 would be E, right? So if I put 13, it'll give me test with a space, but not test space E. Yeah, see, there's no E. But then if I expand this to 14, 14 is the second letter of this third word, which is X. But instead, we'll get everything up to that, which is test space E. There we go. So that's how substring works. And then some other ones that are definitely fun to play with is .replace. It'll replace all instances of the given character or by extension a string in the string. So say I want to replace all test. Oops, I'm going to make that a string. Test with Java. So now there's only one occurrence of test in here. So I'm going to run that and it'll say ABC Java example string because I replaced the word test with the word Java. Say I want to replace TE with JA. AB just example string, just like that. And this is really fun because you can make like almost like a code generator out of this. You can take a string, really muddle it up, and you're the only one that knows what to remove afterwards. Like for example, I'll replace all S's with O's and all B's with exclamation marks. And then someone reads that string after it's gone through that program, they won't know what it is. But then you can run a reverse of the program where you replace all exclamation marks with their respective letters, etc., etc. Then you get back into like, oh, this is what the actual string means. So you can make like a cool code generator program using this replace function. Replace first replaces only the first index, or sorry, not the first index, first instance of the character or string. So that's another flavor of it. And then we have these four, which are extremely self-explanatory, so I'm not going to really get into them too much. Does the string end with character? This returns you a Boolean. Does the string start with a character? Returns you a Boolean. To uppercase gives you back the string in full uppercase. and 2 lowercase gives you the string back in lowercase. So all this fat piece of like comment code that I hope you guys have not typed out word for word. I really hope you guys haven't gone and done that. You can find it on the GitHub, and I will, like I said, I'll link that down in the description of this YouTube video. Essentially, the GitHub is a place where you can see all the files that I can see on my computer, except you won't be able to necessarily edit it because me, Mustafa, and Viva work on this same Git repository. So we don't want you guys accidentally like Control-A deleting everything, and then we're trying to teach something and all of a sudden it just disappears out of nowhere. So yeah, we don't want that to happen. So that's why we've given you guys read access to it. You guys can check it out, and then you can copy paste this if you'd like. Like generally, this is like almost like a mini cheat sheet for you guys, and I want you guys to copy paste it because at the beginning when you're learning all these methods, it's kind of hard to figure out where to go with them. I will say though, one thing that's extremely helpful in Java is that you get like a description of exactly what each of these methods do. Except it will use a lot of jargon, which you won't really understand at this point, but you can always look up those words if you're a little bit confused about them. So now that I've taught you both Boolean logic and string methods, the very last thing I want to teach you guys is basic comparators with integers. So let's make an integer right here. Int b equals 5. And then let's do int c equals 17. So you guys know 5 is less than 17, right? So how do we represent that in code if I want to check whether b is greater than c or c is greater than b? Well, it's just like math. You use the symbols of less than, greater than, but there's something special about the equal sign, which I'll get to soon. So let's make some cases for this. If the integer b is greater than the integer c, we're going to print out b is bigger than c. But let's say else if, remember we're using this else ifs here, c is bigger than b, then we want to print out, guess what? Ooh, c is bigger than b. And then finally, because we're just using an else here, because if it's not greater than and it's not like less than, it's obviously equal to each other. So we're going to type in system.out.println. They are equal. So now I'll run this, and obviously since b is less than c, it'll run this second line, which is c is bigger than b. See what it spits out here? C is bigger than b. Oops, forgot to remove that right here, but yeah. It prints out right there, c is bigger than b. Now if I actually, b has a glow up and changes to 20. Now b is bigger than c. And then say they both turn to 17. They are equal. So one thing that you guys can't see here, because it's implied how to check if they're equal, because you check if it's greater than or less than, but say that you only want to do something if they're equal and not if they're greater than or less than, right? So I'm going to have to check, okay, b equals c. Oh, but wait, I'm getting an error for some reason, right? Which is cannot convert from it into Boolean. Now, looking at this, it makes no sense. You're like, where am I using a Boolean here, like at all, right? But the reason it's saying that is because what you're trying to do here is say when we assign integers and or assign primitives, we use a single equal sign, right? So to tell Java that you're not setting b equal to c, but instead you're checking if b and c are equal, you add another equal sign. And then the errors go away. Basically, when you have one equal sign, it's an assignment. You're saying this is now equal to this. But when you're doing a double equal sign, you're checking, is this equal to this? So I can do they are equal because b is equal to c. And again, think about this in terms of booleans, because if b is equal to c, it returns true. That is simply a true statement. So now you can treat that as a boolean. So if b equals c, I can type in true, right? But say b was 16, this whole thing would be false. And then the if statement would skip itself. And you can chain these. Say I have a int a. And if b is bigger than a, right? But here's where I use the parentheses. This is where it's important. If b is bigger than a and b is also less than c, then we know b is between a and c. Let's check that out for ourselves. So is b greater than a? Yeah, looks like it. B is bigger than a. 16 is greater than 14. Now, is b less than c? Yep, 16 is less than 17. So it should print out b is between a and c. There we go. And let's say I want to have it print out something if, oops, not those two. Some random string. I want to print out something if b is greater than a, or let's check if it's greater than a or it's less than 10. So if b, let's go to 9, right? Run that. It's going to return true because, well, b9 is less than 10. But then let's say I change b to 11. Now it is more than 10, so this will return false. But also it's not bigger than 14, so this will also return false. And two falses with an or is in general false. Like the whole thing will be false, which is why we won't see a print. And finally, if I change this to be 15, oops, 15. Then I'll get a true, because b is now greater than a, even if it's not less than 10. One last thing, if you want to do a greater than or equal to comparison, because right now if I did 14 and 14, this would actually still return false because 14 is not greater than 14, it's equal to 14. So to have a greater than or equal to comparison, you just add an equal sign after the comparator. So now it returns true because 14 is greater than or equal to 14. All right, that wraps it up for scopes, modifiers, booleans, and if checks, string methods, and comparators. This was a huge video, guys. Thank you for making it to the end here. I have one last thing to leave you guys off with, and you can go have fun on the weekend, because we all have fun on the weekend, right, guys? And that would be in project files. If you go on the GitHub, you can navigate here as well. I have a project for you guys. You are going to make a string sorter. And essentially what you're going to do is you're going to define a string in your main method, and you are going to have a bunch of if checks and booleans that sort the string into buckets and print out which bucket it's in. Like for example, if you have a string that starts with A and ends with C, it belongs in bucket A. But say it also has a letter B at index 2, then it belongs in bucket B as well. So then you would print out A and B. So this will require a bunch of booleans, at least at this level for you guys, it'll require you to create a bunch of booleans to store which buckets that this string is in due to if checks. And then you will use those buckets in more if checks to print out which buckets are in, so you can tell the user which buckets these strings are in. I have some hints down here for you guys, and this actually is a genuinely difficult project for what I've taught you guys. It's using the knowledge I told you like immediately off the bat on a relatively high level. So please, please, please tell me if you have any questions. I can definitely sit with you one-on-one, get in a Discord call with you, or anything, as long as it helps you clear things up. You can also ask questions in the software chat. We have plenty of software members that are knowledgeable enough to answer your questions, even if it's not me. So let them know if you have any questions if I'm not immediately available. And that wraps it all for today, guys. Thank you so much for waiting for this video. I know it took a while. It was just really hard to get everything in one place. And I will see you guys next time. Bye.